Welcome to the DIY Honda Garage channel. The DTC P2135 code refers to a malfunction in the throttle position (TP) sensor related to incorrect voltage correlation between sensor A and sensor B. This code typically indicates a discrepancy in the signals sent from these sensors, which are crucial for accurate engine management and smooth operation. Located on the throttle body, the TP sensors monitor the position of the throttle valve, communicating with the Powertrain Control Module (PCM) to regulate air intake and engine performance. Beyond maintaining optimal engine performance, the throttle position sensors play an integral role in ensuring safety by preventing unintended acceleration scenarios. The presence of this DTC requires immediate attention, as it can affect vehicle drivability and emissions levels. Understanding this code is vital for efficiently diagnosing and repairing the issue while utilizing Honda's diagnostic tools effectively. DTC P2135 indicates an issue with the throttle position sensors A and B, which are responsible for gauging the throttle valve's position on your Honda CRV. Positioned directly on the throttle body, these sensors generate voltage signals that are interpreted by the PCM. The PCM utilizes these signals to control engine functions like airflow and fuel delivery for optimum performance. A correlation error occurs when the voltage signals sent from these sensors do not align, or when one sensor reads a position that is inconsistent with the other. This inconsistency can mislead the PCM, potentially leading to poor engine performance and increased emissions. Proper understanding of their role and location is essential for accurate diagnosis and repair. When encountering DTC P2135, several possible causes must be evaluated. A faulty throttle body can lead to incorrect voltage readings from the TP sensors, as the sensor's ability to measure valve position accurately may be compromised. Wiring issues, such as frayed wires or poor connections, can disrupt the electrical signals sent to the PCM, causing erroneous DTCs. In some cases, a defective PCM itself could be the root of the problem, not processing the signals correctly. Additionally, intermittent electrical issues can create sporadic DTCs. Therefore, a thorough inspection of the throttle body, wiring, and PCM is necessary for effective troubleshooting. Drivers may observe several symptoms when DTC P2135 is present. One of the most immediate indicators is the illumination of the check engine light on the dashboard, signaling that something is amiss with the engine management system. Another common symptom is poor acceleration response. The vehicle may struggle to accelerate smoothly, causing frustration and potential safety concerns. Drivers might also experience stalling or hesitation during acceleration, which can be both alarming and hazardous in traffic situations. Understanding and recognizing these symptoms can guide drivers in seeking timely repairs, preventing further complications with their vehicle's performance. The first step in troubleshooting DTC P2135 involves turning the ignition switch to the on-to position, which powers up the vehicle's diagnostic systems without starting the engine. This allows for the activation of various electronic components, including the throttle body system. Next, clear the DTC using the Honda Diagnostic System HDS, a specialized tool designed for Honda vehicles. Resetting the DTC prepares the system to perform a fresh evaluation of the throttle components. Following this, conduct the ETCS, Electronic Throttle Control System, test to assess the throttle body's proper operation. The HDS will monitor the signals from the TP sensors and check for any immediate discrepancies or faults, helping to pinpoint any immediate issues present within the throttle system. In this step, begin by turning the ignition switch to the lock 0 position to ensure safety and accessibility to the throttle body. Disconnect the intake air duct from the throttle body, providing clear access to the throttle valve for examination. With the ignition switch still in the on position, clear the DTC once more to reset the system again. This step is essential as it allows the throttle to be evaluated without interference from prior codes. Visually inspect the throttle valve's operation to ensure it returns to its fully closed position when electrical power is applied. If the valve does not operate correctly and fails to close fully, it may indicate a defective throttle body that will require replacement. A properly functioning throttle valve is crucial for maintaining the correct air-fuel balance, leading to optimal engine performance. For the third troubleshooting step, start by ensuring the ignition switch is turned to the lock 0 position for safety. Next, utilize the HDS to jump the SCS, Service Check Connector line, enabling diagnostics to assess the throttle position circuits effectively. Disconnect the PCM connector, specifically connector C, which contains 49 pins, facilitating necessary access to check the internal circuit continuity. With the ignition off, perform a continuity test between test points on the PCM connector, specifically between pin number 30 and number 31. These points correspond to the throttle position sensor signals, and determining whether continuity exists can reveal whether the sensor connections are intact or if there are underlying wiring issues. If continuity is present, this suggests that the wiring is functioning properly, and the issue may potentially lie within the PCM or its programming. In this final troubleshooting step, begin by disconnecting the throttle body 6-pin connector to isolate the throttle position sensor wiring. Continuing with continuity checks, verify the continuity between test points 1 and 2 on the disconnected circuit. Again, use the same pin numbers in the PCM connector as identified in the previous steps, assessing the continuity between the left green wire and the red wire. If continuity exists, this indicates that there is a short circuit between the throttle position sensor A and B lines, which must be repaired. If no continuity is observed, the wiring is likely intact, leading you to replace the throttle body itself if earlier inspections indicated a fault. The successful completion of this troubleshooting step ensures you are either addressing a wiring defect or preparing for a component replacement. After completing all necessary repairs related to DTC P2135, the final verification process is crucial. Start by reconnecting all previously disconnected connectors to ensure proper assembly before testing the system. Turn the ignition switch to the on position to power up the engine management system. Next, reset the PCM using the HDS, allowing for a fresh assessment of the vehicle's systems following the repairs. This reset clears any prior diagnostic trouble codes and prepares the system for its new baseline condition. It's also recommended to perform the PCM idle learn procedure, which helps the PCM recalibrate to engine conditions post-repair. Finally, check for any pending or confirmed DTCs again to ensure the issue has been resolved, validating that the repairs were successful and the vehicle is back to normal operation. For preventive maintenance to avoid DTC P2135 in the future, it's beneficial to routinely inspect the throttle body and its components for signs of wear or damage. This inspection includes checking the throttle valve for proper movement and ensuring that the wiring is intact. Keep an eye out for frayed wires or loose connections that could compromise signal integrity and lead to problems down the line. Periodic maintenance checks can prevent electrical issues from becoming problematic in the first place. Updating the PCM software when available can also enhance performance and avoid glitches that may result from outdated programming protocols. Implementing these regular maintenance practices can help maintain reliable engine performance and prolong the life of critical components. In summary, DTC P2135 highlights the importance of the throttle position sensors and their role in engine performance. A correlation error between these sensors signifies the need for immediate investigation, as it can result in impaired drivability and increased emissions. Diagnosing the issue involves a series of detailed steps, including checking wiring, assessing the throttle body, and verifying PCM function. Each step plays a crucial role in diagnosing and ultimately resolving the code. Preventive maintenance practices are equally essential, as they can help mitigate the risk of encountering similar issues in the future. Understanding this DTC empowers Honda CRV owners to maintain their vehicles effectively, ensuring safety and optimal performance on the road. Please like and subscribe to the channel. See you next time.